Hello, everybody. Thank you very much for coming here today. My name is Yanir Heinik, and I'm the co-founder and CTO of Pixie Holographic Imaging, and it's an honor to present Pixie to you today. I'll start by exploring the evolution of imaging technology, which has undeniably become an integral part of our daily lives. I mean, from taking photos with your smartphones through aiding vehicles in driving autonomously and navigating autonomously to home application, industrial applications, imaging systems are everywhere. The rapid advancements and widespread adoption of cameras have really shaped this industry into what we see today. Now, despite accomplishments in miniaturization, in ease of integration, and in cost reduction, the core physics of cameras have remained virtually the same since the era of film photography. 2D cameras treat light as rays, advancing in straight lines and being focused by a lens onto a light-sensitive plane, either a chemical film or an array of photodiodes, to create two-dimensional images, either in color or monochrome. But that's about to change. Pixie's groundbreaking innovation can transform 2D cameras into advanced imaging devices, capable of delivering both high-quality color images as well as detailed and accurate depth maps. Let's take a closer look at our invention. Pixie aims at revealing light's wave-like nature. Now, those waves of light contain information on the color of the source, as well as the distance to it. A Pixie camera looks just like a 2D camera, only instead of focusing the light on a color filter array, which is common to most RGB cameras, the light is focused on a holocoder, which is placed right on top of the raw sensor. Now, this holocoder is a Pixie-designed diffractive optics element. The raw sensor underneath the holocoder now records diffraction patterns, which encode within them both the color information and the depth information. Then, Pixie algorithms analyze and process these diffraction patterns, both analytically and deterministically, to yield the RGB image, as well as an IR image and a depth map. Now, how can this revolutionize machine vision, you ask yourself? So to answer that, we need to revisit traditional technology, the one that treats light as rays and uses a color filter array to generate the color information. Now, although this technology dominated machine vision for decades, it suffers from inherent limitations. For example, imaging under low light conditions, when light is scarce due to the filtration on the color filter array, or the absence of physical depth information. Now, these limitations truly impair the ability of cameras to perform complex machine vision tasks like 3D SLAM, object detection, 3D modeling, and the such. Now, of course, over the years, advancements have been made to cope with these limitations. For example, stereo cameras, as well as structured light and time-of-flight devices, add valuable depth information to perception systems, but they suffer from limitations as well. For example, imaging reflective surfaces or imaging under abundance of ambient light conditions. But above anything else, they dramatically add to the complexity and cost of perception solutions. Now, the only way to truly revolutionize machine vision is to eliminate these trade-offs. You shouldn't compromise between complexity and cost, and between form factor and weight. And with Pixie, you don't have to. You get it all. I want you to meet Erez, our system engineer, and Charlie, the office dog. Both of them are the stars of this medium-range demonstration movie, which was filmed with a Pixie camera. Both the RGB channel and the depth channel you see here come from the same holographic sensor. Now, this is a key feature of our technology, where all the information channels are natively fused and completely synchronized because they come from the same captured data. Now, in this short-range demonstration of a packing application, also filmed with a Pixie camera, you can see that although the 2D image is of high quality, you can't really tell if any of the cans in the image are of different height. I think that is pretty evident from the depth map. You can see that 2 of the cans have different height, a difference of a few millimeters in this example. Pixie offers a groundbreaking solution to perception applications, delivering both high-quality color images as well as accurate depth maps from a single snapshot on a single sensor. And we do all of this in the cost structure and simplicity of 2D cameras. We are completely agnostic to the underlying sensor or the lens design, making us relevant for any application and fitting any use case. We are a true drop-in replacement to existing workflows. On behalf of the Pixie team, I want to thank you very much and invite you to visit in our booth. We have a demo ready for you there and would love to see you. Thank you very much.